This is the coding action video for Chapter 10. In Chapter 10, we implemented our own hooks in our blog application. First of all, we implemented a useDispatch hook, which just makes use of the useContext hook and then returns the dispatch function from the state context. We also implemented hooks for the post state, which does the same but returns the post state, and the user state, which also does the same but for the user state. Then we implemented a useTheme hook, which returns the theme context by using a context hook. And then we implemented API hooks, which provide us with resource hooks to our various API calls. This is very useful because if the API changes later on, we can just change the API calls in api.js, like here, and the API will automatically be working in our application. So it keeps the API calls and the connection to the backend in one file. As we can see here, we simply define hooks for the different API calls and then return resource hooks for these calls. Next, we defined the useDebounced undo hook, which implements the bounced undo redo based on the useUndo hook and the useDebounce hook, specifically the useDebounced callback hook. As we can see, we have implemented it here. We also specified a timeout that you can set the different timeout if you want by passing the first argument to the useDebounced undo hook. And then we used useCallback so that we are not redefining the setter function every time that the hook gets triggered again. This is a little performance optimization. And finally, it returns the content, a setter function, and all the undo stuff, which is the history and the undo and redo action functions. Then finally, we created an index.js, imported all of our hooks there, exported all of our hooks using this export is the normal export, and then we use the star, the asterisk, which exports everything from the API file. If we now run the first code example, we can see that our application still works the same way as before, as we have not actually implemented our hooks in the application yet. In the second code example of Chapter 10, we used our custom hooks in our application. So as we can see here, we are importing a bunch of hooks from our own hooks folder, and we are using them here. So we can, for example, get the user state by using useUserState. We can get the dispatch function by using useDispatch. We can get the post and create post object and create post function by using the useAPI create post hook. And we can use the useDebounced undo hook as well here. We are using it instead of the useUndo hook. And now we have the whole debouncing logic separately from this create post component. So if we want to use debounced undo in another part of our application, we can do that now. We could even release useDebounced undo as a library and offer it for other applications as well. In the other components, we also used our hooks. So for example, here we used the useTheme hook and so on. In the second code example, we have implemented our custom hooks in our application. So we can now see that everything works the same way as before, but now for example, the useDebounced undo hook is used for debouncing the undo history. So we can take a look here by entering some text here. And now it works the same way, but we're using our custom hook for this functionality now. In the third code example of Chapter 10, we implemented local effect hooks. So these hooks are not used across the whole application, but they're just used in one component. So we kept them in the file for the corresponding component. In this case, we implemented a useLogin effect, which is only used in the login component. And it still makes sense to keep it in a separate hook function, because then we can more easily read the code, and it will also be the code for the actual component will be less cluttered, and we have logic and UI logic in separate functions, which is good for the single responsibility principle. And as we can see, we can use it like an effect hook, but we have to pass all the dependencies on it to it, which are user, dispatch, and set login failed. And then once it gets all the dependencies, it can create and return the effect hook. And the effect hook is just the same as before now. We also did a use register effect hook, which is also a local effect hook. It works pretty similar, but for the register component. In the third code example, we implemented the local register and effect hook and login effect hooks. We can see that login and registration still work the same way as before, but we are now using a local effect hook to deal with the actual login. So as we can see, we can log in just like before. In the fourth code example of chapter 10, we implemented tests. So by default, Create React App already creates a test here, which just checks if the application renders without crashing. But additionally, we define tests for our hooks here. So we defined a counter hook to learn about tests. The counter hook just simply gets an initial state and then provides increment and reset functions. And then we can test this hook by, first of all, testing the signature of the hook, so we can see if the result of the count of the initial state is 0, and if the increment function exists and is a function. Then we test if it increments the counter by 1, if we call the increment function by using the act function. The act function you can execute a function from the hook, and then it will wait for it to finish, and then later we can expect and check if the result of the hook is different now. We also checked if the initial value works and if incrementing after the initial value works as well. And then finally we tested if the reset function works by setting an initial value and then a new initial value and then re-rendering our dummy component, which is used for the tests. And we need to do this because otherwise the hook, it will not know that it should re-render when this value changes, because we're not dealing with an actual component here. It's just a test component within the React testing library. So we have to tell the React testing library when to re-render the dummy component. So now we are setting the initial value to 0. We are initializing the hook. Now the initial value will be 0. Then we set a new value which corresponds to like a prop changing, and then we re-render, which happens automatically in React when the prop changes. Then we can call the reset function, and now we expect the count to be the new initial value. We also wrote tests for all our other functions. They look pretty similar. We test the signature first, then we test if the setter function works, we test if the undo history works, and it's the same for the others. We test the signature and the functionality of our hooks. Writing tests makes sense, especially when exporting our hooks as a library for other people to use, but also for our local projects, so we can always be sure that when we change the hooks later on, they still have the same signature and they still work in a similar or the same way as before. As we can see, we also have tests for the theme and state hooks, so these are all pretty similar tests. Now let's move on to actually running the tests. As we can see, I have already started chapter 10 example 4 here. This is important because the tests actually depend on the server to be running, so they can test the API hooks. And then we can go into the chapter and run npm test. Now this says no tests found to files changed since last commit, because we did not actually change anything. So to run all tests again, we have to press the A key. If you didn't run the tests before, it should probably run them instantly, but I have, so I will have to press the A key. As you can see, all our tests passed. It also shows us how long the tests took. And now it's in watch mode, so that means that when we change something in our code or something in our, for example, let's go back to these original tests, and then now we change this to 1 and then save, and now it will run the tests again, and we can see that the hook test for use counter now fails. It says we expected it to be 1, but it was actually 0. So we can see that our test is now failing. But if we added a 1 here, which sets the initial state, and save again, it will run the tests again, and now we can see it passes again because now the initial value is 1 and we expect it to be 1.